Welcome to Mickey Study Circle channel. In this video, we shall see how to solve the given numerical using the relations from the merchant circle analysis. Coming to the problem statement. During a metal cutting test under orthogonal conditions in a lathe with a tool of rake angle 20 degrees with a depth of cut of 3 mm and a feed rate of 0.38 mm per revolution, the following data is recorded. The average chip thickness is 0.89 mm and the horizontal component of the cutting force, which is also the cutting force that is Fc, is 1600 Newton, and the vertical component of the cutting force, which is the thrust force, is equal to 2340 Newtons. So we need to calculate the coefficient of friction at the tool chip interface and also the shear plane angle and the shear stress at the shear plane. So now let us list down the parameters that is given in the problem statement which can be used to solve the numericals. So first the rake angle is given to us, which is alpha and is equal to 20 degrees. And also the depth of cut is given to us, which is equal to D or B, which is equal to 3 mm. And then the feed rate is given to us, which is equal to 0.38 mm per revolution. And also the average chip thickness is given, that is the value of Tc, which is equal to 0.89 mm. And next we have got the other parameters, that is Fc is equal to 1600 newtons, which is the horizontal component of the cutting force, and also the thrust force, which is the vertical component. After having known the parameters it is given to us, now let us go to compute the values that is asked for. So first we will consider the coefficient of friction. So the coefficient of friction is given by the ratio of the frictional force to the normal force, and in turn we have got the separate formulas for the friction force and also the normal to the friction force. So the friction force is given by the formula Fc sine alpha plus Ft cos alpha divided by the normal force, which is given by Fc cos alpha minus Ft sin alpha. So we know the values of Fc and Ft, which is equal to 1600 and 2340 newtons respectively, and also the value of alpha is 20 degrees, that is the rake angle. So upon substitution, we'll be getting the value of the coefficient of friction as 3.905. So this is the first parameter. The second parameter is the shear plane angle. So we know the shear plane angle is given by phi is equal to tan inverse of r cos alpha divided by 1 minus r into sin alpha, where r is the chip thickness ratio. And we need to compute the chip thickness ratio here. So here the average thickness is, so the value of r is given by the ratio of the uncut chip thickness to the chip thickness. So the uncut chip thickness can be assumed to be equal to the feed in case of the turning operation. So it is equal to 0.38 divided by the average chip thickness, that is 0.89. So upon calculation we get the value of R to be 0.426, which is the chip thickness ratio. So now we'll use this chip thickness ratio and also the value of alpha to compute the value of phi. So upon substitution we'll be getting the value of phi to be equal to 25.17 degrees. Next we need to compute the values of the shear stress. So the shear stress is given by the formula tau is equal to the shear force divided by the shear area. And in turn, we have got the shear area given by the formula B into T divided by sine phi. So now first we need to compute the values of the shear force. So the shear force is given by the mathematical model Fc cos phi minus Ft sin phi. So the value of phi is known from the previous step. So upon substitution of the phi and also the Fc and Ft values, we get the magnitude of the shear force to be equal to 452.86 newtons. And also the shear area to be equal to B into T. So B can be assumed to be equal to the depth of cut, that is 3, and then the uncut chip thickness ratio, which is nothing but the feed. So 3 into 0.38 divided by sine of 25.17 degrees. So the value of the shear area will be equal to, it will be equal to 2.68 mm square. So this is the shear area. So now we can compute the value of the shear stress as 452 divided by 8.86 divided by 2.68, which will be equal to 168 megapascals. So it will be equal to 168.9 megapascals. So this is the value of the shear stress. This is the value of the shear force, the value of the shear angle, the value of the chip thickness ratio, and the value of the coefficient of friction. So with this, we complete the computation of all the parameters that is asked in the